If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. An inductive coil of resistance 15 ohms and inductive reactance 42 ohms is connected in parallel with a capacitor of capacitive reactance 47.6 ohms. The combination is energized from a 200 volt 33.5 Hz AC supply. Find the total current drawn by the circuit and its power factor. Draw to the scale the phasor diagram of the circuit. Solution. First of all, we will draw the circuit diagram for this question. So as we can see, the inductive coil of resistance 15 ohm and inductive reactance 42 ohms is connected in parallel with a capacitor of capacitive reactance 47.6 ohms. So as we can see, the R and L, the resistor and inductor are connected in series and capacitor is connected in parallel to this. The value of this resistance is R is equal to 15 ohm. The value of inductive reactance XL is equal to 42 ohm. Capacitor have capacitive reactance of XC is equal to 47.6 ohm. Then supply voltage is AC and it is 200 volt 33.5 Hz. Then we have to find total current. So this will be the total current I. Let's say this is current I RL and this is current IC. Let's say this is impedance Z1 and this is impedance Z2. Now first of all we will find total current drawn by the circuit. So to find the total current, we have to find total impedance first. So Z1 is equal to, Z1 will be equal to R plus J XL. The value of resistance is 15 plus J. The value of XL is 42. Now it is in rectangular form. So its equivalent polar form will be under root of 15 square plus 42 square at an angle of tan inverse of 42 by 15. So it is under root of 15 square plus 42 square. So it is 44.59. 44.59 at an angle of tan inverse of 42 by 15. 70.34. 70.34 degree. This is the value of Z1. Now it is the rectangular form. And this is the polar form. Now for Z2, for this Z2 will be equal to R minus JXC. Here the value of R is 0. So it will be minus JXC. So minus J, the value of XC, the value of capacitive reactance is 47.6. 47.6. Now this is in again rectangular form. So its equivalent polar form will be 47.6 at an angle of minus 90 degree. So this is the polar form of Z2. Now we have Z1 and Z2 in rectangular form as well as in polar form. Now we can find the value of total impedance Z. So total impedance is equal to Z is equal to Z1 into Z2 divided by Z1 plus Z2. Now we will take Z1 and Z2 in polar form. So Z1 in polar form will be this value, and Z2 in polar form will be this value. And we will take Z1 and Z2 in rectangular form for the denominator, because here we are doing addition, and addition and subtraction are better performed in rectangular form. So here for this Z1 we will take the rectangular form of this Z1, and then we will take the rectangular form of Z2. The rectangular form of Z2 is this value. Now we will simplify this. So it will be 44.59 multiplied by 47.6. 44.59 multiplied by 47.6. So it will be 2122.484 at an angle of, now this will be 70.34 degree plus minus 90 degree divided by, now here we have to add the real part. So here real part is only 15 and imaginary part will be 42. This 42, then plus minus 47.6. So it is 5 minus J 5.6 minus J 5.6. Then this will be 2122.48 at an angle of, now this will be 70.34, then plus in bracket it is minus 90, so it will be minus 90. It is minus 19.66, minus 19.66 divided by, now here it is in rectangular form, so in polar form it will be under root of 15 square plus minus 5.6 square at an angle of tan inverse of minus 5.6 divided by 15. So this will be 2122.48 at an angle of minus 19.66 divided by, now this will be under root of 15 square plus in bracket minus 5.6 bracket complete square, 15 square plus minus 5.6 square. So it is 16.01 at an angle of tan inverse of minus 5.6 by 15, minus 5.6 by 15. So it is minus 20.47, minus 20.47. Now if we further simplify this, So it will be 2122.48 divided by 16.01. 16.01. So it is 132.57. 132.57 at an angle of minus 19.66 minus 20.47. So it is 132.57 at an angle of minus 19.66 minus 20.47. 20.47. So it is 0.81. This is the value of total impedance Z. So total impedance Z is equal to this value and its unit will be ohm. Now we have the value of Z. We also have the value of current I. The value of current I is not given, but the value of voltage is given. So the value of voltage is 200 volt. We have to find the current I. The value of voltage is given, it is 200 at an angle of 0 degree. Now using Ohm's law for AC circuit, we can find the value of current I. So current I will be equal to V upon Z. So the value of voltage V is 200 at an angle of 0 degree divided by impedance Z is 132.57 at an angle of 0.81 degree. So it will be 200 divided by 132.57. 200 divided by 132.57. So it is 1.50. It's 1.5 only. 1.5 at an angle of, this will be 0 degree minus 0.81. So it will be minus 0.81 degree. This is the value of current I and its unit will be ampere because it is current. So its unit will be ampere. Now next, find the total current drawn by the circuit. So the total current drawn by the circuit will be 1.5 ampere. Now we can also find the IRL and IC. So first of all we will find, let's say we will find IC, the current through the resistor. So the current through resistor IC will be equal to, again according to Ohm's law for AC circuit, it will be V upon impedance of this branch is Z2 and voltage across this branch is same voltage V because it is connected in parallel. So voltage will be V and impedance will be Z2. So V divided by Z2. The value of voltage V is 200 at an angle of 0 degree divided by Z2. Now Z2 again we will take in polar form. So here we can see this is the Z2 in polar form. This is the value of Z2 in polar form. Now if we simplify this, so it will be 200 divided by 47.6. That is 4.20. 4.2 at an angle of, now this will be 0 degree minus 90 degree. So it will be plus 90 degree now. This is the value of current IC and its unit will be ampere because it is current. Then next we can find the value of current IRL. So current IRL will be equal to again V divided by, now for this RL branch the impedance is Z1. So this will be Z1. Again same, the value of voltage V is 200 at an angle of 0 degree divided by Z1 in polar form. So Z1 in polar form is this value This is the Z1 in polar form. Now if we simplify this, so it will be 200 divided by 44.59. It is 4.48. 4.48 at an angle of, now here this will be 0 degree minus 70.34. So it will be minus 70.34 degree and its unit will be ampere. So this is the value of IRL. Now we have the value of total current and IC and IRL. We also have the voltage. We also have the total impedance. Now next, find the total current drawn by the circuit and its power factor. Now we have to find the power factor. Now here we can see power factor will be equal to power factor is equal to cos phi, where this phi is the phase angle difference between voltage and current. So it is, here we can see we have to take the angle from total current. So angle from total current I is, it is minus 0.81 degree, minus 0.81 degree ampere, minus 0.81 degree. Now here it is negative, that means it is, the current is downside, so it will be cos of minus 0.81. It is 0.999, 0.999. So this is the value of cos phi. Now we have the value of cos phi. Then next is draw to the scale the phasor diagram of the circuit. Now we have the value of cos phi also. First of all, we will write the value of voltage. So voltage is 200 at an angle of 0 degree. The current I is equal to, the current I is 1.5 at an angle of minus 0.81. 1.5 at an angle of minus 0.81 degree ampere. Then total impedance, we don't need the total impedance, we need, for vector diagram we need IC. So IC is equal to 4.2 at an angle of 90 degree, 4.2 at an angle of 90 degree ampere, and IRL is equal to 4.48 at an angle of minus 70.34, minus 70.34 ampere. So this is the value of IRL. Now we can draw the phasor diagram using this data. So first of all, we have to take voltage as a reference because its angle is 0 degree. So we will take voltage as a reference. This will be our voltage. V is equal to 200 at an angle of 0 degree, so 200 volt. Then current I. Now here we can see current I value is 1.5 ampere and it is at an angle of negative 0.81 degree. So here this will be our current. Current I is equal to 1.5 ampere and its angle will be very small, it is 0.81 degree. Then IC. Now IC is, the angle is positive 90 degree, that means it will be somewhere here, and it is of 4. IC is equal to 4.2 ampere and it is 90 degree. Then IRL. So IRL means 4.48 and its angle is minus, that means it is downside, and it is 4.47, 4.48. So it will be somewhere here. IRL is equal to 4.48 ampere, and its angle is from here to here, it will be minus 70. It will be 70.34 because it is downside, that means it is negative. So this will be the vector diagram. This is a vector diagram for this question. If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. Thank you.